For the math part, we are going to prove how theta is related to the angular velocity of the disk. First, we define some parameters, and we have some assumptions. 1. Treat these parameters as constant, since they change slowly in reality. 2. The disk rolls without slipping, which means the velocity of point A is 0. 3. The disk is thin. 4. RC is equals to 0. RC is the distance over here, and 0 means that G is on this axis. We know the direction of omega p and omega s, so we can represent omega in this form, where J is the unit vector in y direction and k is in z direction. Later, we will consider several properties of the disk and use them to finish the proof. For the angular acceleration, we differentiate the angular velocity and separate it into two terms. Since this part and this part is constant, so we get 0. And for these two parts, we use the property of vector differentiation and get the answer like this. So alpha is equals to omega s times omega p sine theta in x direction. For the velocity of point A, we assume there is no slipping, so it is 0, and we get r omega s equals to a omega p. And since a is equals to rc plus r cosine theta, and rc is 0, so plug this into the equation, we can get the relation between omega s and omega p like this. And for the force acting on the disk, we have these three equations. Since G is stationary due to the assumption, so they are all equals to 0. And we get Fax and Fay equals to 0, and Faz is mg. Finally, we apply the Euler equation, where m is the sum of the moment, I is the moment of inertia, omega is the angular velocity. This is the three-dimensional form, and by inspection, we have this condition. Note that the x, y, z in these equations are local axes, which is attached to the disk. Plug this condition into the equations. We found that only the first equation is non-zero. By this assumption, we can calculate the moment of inertia by some physics formula. And since this is the sum of moment in x direction, it can be also represented in this by physics. Then plug all these parameters and this equation into here. We get the relation between omega p and theta. It is true that when theta becomes smaller, omega p becomes larger.